Hi, I'm Larry Puckett, the DCC Guy. Today I want to show you how you can use block detectors like this NCE BD20 here to keep track of your locomotives and your cars and other rolling stock all over your model railroad, specifically though in places like a helix or a staging yard or other areas of hidden track. So let's go ahead and get started with that. So first I'm going to show you how these BD20 block detectors operate with a demonstration right here on the bench top. And then we'll go on over and I'll show you how it actually works on the finished helix to keep track of the trains as they move up and down the helix. And then once we finish with that part of the video, I'll move on and show you how it's all wired up inside the helix itself. So let's go ahead and get started with how to set these up to operate on your model railroad. Okay, I've got everything set up here on the bench top so we can take a look at how block occupancy detection is going to work in the helix. And I'll show you this. This is the display that I'll have. And at each one of these green dots, there will be an LED. And as the locomotive with its train goes up the helix, the light or the LED for that particular level will come on. Now the helix itself comprises 4.5 complete turns. So if I divide that by 3, that means I've got 1.5 turns per level. So the light will come on as the train ascends 1.5 turns on the helix. So this is what will be mounted on the fascia in front of the helix. And I do that because, you know, people like to be able to see where their train is, what's going on. Now, the way I'm going to be able to do this is, these are called a block occupancy detector. Let me zoom in just a little bit for this. So this is a BD20, and it's made by NCE. You could also use the LMID, made by DCC Concepts. It looks almost identical to this one. And what we have here is a little black thing that looks like a headstone on a grave, and that's called a current sensing transformer. And the way this works is you run the feeder wire that goes from your main power bus or your sub bus to your track. You run it through here 1 to 5 times. And each time you run it through here, it increases the sensitivity. So I found that 2 is a pretty good value for a 5 amp booster. And they explain this in the manual that comes with it. Okay, so as current flows through this wire to the track, whenever there's a locomotive or a lighted car or anything that represents a power load, then current will literally flow through here. And it will induce a current in this current sensing transformer. And then the electrical circuit on this board will interpret that sudden change in current flowing through this device as a train being in the block. And it will do several things. For one thing, there's a little LED right here that'll light up if you've provided power for it. It will also send out a logic signal. So this can be used with a computer interface so that you could use it with JMRI, for example. You can use this with a standalone logic board, which is what I do. And I'll get into that in a future video. It's a simple matter to hook this up. The instructions are quite clear on it that come with it. This is 18 gauge wire, and that's the largest I could fit through here and get 2 turns. It was really tight at that, but I was able to do it. So I kept it very short. It's about 6 inches long or so. And that way you get very little voltage drop because I use a 14 gauge bus wire the rest of the way. Let me show you one other thing before we go on. Right here, they provide 3 holes on the circuit board for you to use a small trim pot. Okay? Now these are a little potentiometer, which is basically acting as a variable resistor. And what that allows you to do is it allows you to increase the resistance on the board, and in doing so, it decreases the sensitivity. So if you get a bunch of false detects due to various reasons, you need to add one of these. For the most part, I've never had to use them before. I put one in here just to show you. So it just simply goes in here. You solder it in place. It has to be one of these small vertical mount type potentiometers. You can see the three little legs, and they go into three independent holes on the board. And you solder it in place, and that's all there is to it. And they talk about that. If you know the resistance value that works on your layout, you could just put in an individual resistor. Okay, so what I've done is I've attached the power supply, and I've used a 9-volt DC power supply. And the positive wire goes into the first screw terminal here, and the negative goes into the number 4 terminal. And they show you this again in the instructions. And then I just inserted the wires from this LED, and it's a little surface mount LED, so it's very small. And it has a 1000 ohm resistor built into it. This is just for demo. But the positive leg of that goes into the positive terminal number 1, and then the other leg goes into terminal number 2. And basically, it's just got a little switching transistor in here that turns this on and off and provides the power to operate it. So let me show you how this works. I've got my Digitrax Zephyr set up here, providing DCC power and control, and I've got it connected with clip leads through this green coil here. So let me show you what happens. Now right now, you can see this light is not lit. Let's take this simple 10,000 ohm resistor here and put it on the track and watch what happens. And you can see that this little light comes on. And that's because it represents a load on this device. It is conducting electricity from one track rail to the other through the resistor, which is 10,000 ohms, and that is enough to light this up. Now, how does that work in reality? Well, if I take a resistive wheel set, and this is simply a pair of intermountain wheels that I've attached a surface mount resistor, 10,000 ohm resistor, here between the wheel and the axle so it completes the circuit. If I put this on here, you can see that this little light lit up. And that's what would happen if you had this attached to a car. So you could put this on a caboose or any other piece of rolling stock, and whenever it's in that block, then that detector is going to light up a light. Okay? And a lot of people do that. They buy these resistive wheel sets, put them on all of their cars, and that way they can detect their cars all over the layout. Now, a simple light bulb will do the same thing. This is a plain old lifelike caboose. It has a light bulb inside of it, and you can see as soon as I put it on, the detector lit up that bulb. Take it off, it goes away. Now, the same thing goes when you put a locomotive on the track, because, you know, that circuit board there, the DCC circuit board, is consuming a certain amount of power, and so it will light up that LED. So that's why, as a train moves through the helix, it's going to successively light up those LEDs on that display, because I'm going to have one of these block detectors connected in to each block on that helix. So there will be 3 different individual blocks in the helix with their own block detector, and every time a locomotive or a car with a resistive wheel set or a light bulb goes into that block, it's going to turn it on, turn the light on the display. When the locomotive and the train passes completely through that block, then the light will go out. I want to show you how I've implemented it here on the Helix. So if you look here, the Helix is now complete, and it's installed here in the corner underneath of the industrial area at Charlottesville. Eventually this will all be enclosed, and there will be the lower basin area at Lynchburg switching area on top of it. And the display that I showed you previously, which you can see in the center of the image here, and we'll zoom in on that in a minute, that's going to be located on the fascia. So it's going to be pulled out from where it is now. I just got it set in there temporarily for this demonstration. And then we'll be able to watch as the train goes up or down through the helix. And I'll show you how that's going to work in just a second. I've got a train set up here. I've got that RS-11 that I previously used. So we've got a locomotive on the front, and we have a lit car. The lifelike lit caboose I showed you earlier will be on the rear end. So we'll be able to detect the front of the train as well as the rear end of the train. And what I want you to do is pay close attention to this display here, because as you can see, there are 3 LEDs in there now. It's kind of hard to see them because they're green against a green background, but when they light up, you'll be able to see them. And they're going to show us as we go up or down the helix. Okay, now, I've got the locomotive on the approach set of track. And right there, you can see a gap in the front of the locomotive. And that is just in front of the re-railer. And as I told you previously when I was building the layout, I put a re-railer at the bottom, and I'll have another one at the top, just to make sure that all the cars that go into the helix will be on the rails. Because the last thing you want is for a derailed car to go bouncing down your helix. Now, that gap that you see in front of the locomotive has a set of plastic rail joiners. So it's insulated from that. So that's the beginning of the first block. And what I've done is inside of the helix, I have cut 2 gaps, creating 3 separate electrically isolated blocks. And each one has a BD20 detector on it that will power up the LED on the display as the locomotive enters each isolated block and proceeds up through the helix. So let's go ahead and do that. Before we go on, I want to ask you to take a moment to subscribe to the channel. It's simple, easy, and free. All you have to do is hit that little red subscribe button, and when the little bell comes up, click on it and click all. Okay, you should be able to see that the first LED has lit. I'll zoom in a little bit closer for you. So that first LED at the bottom of the helix display has lit up green, just as that locomotive crossed that gap. Okay, I'm going to speed it on up. We'll do about 30% of full speed. It takes about 2.5 minutes for a train to go from the bottom of the helix to the top of the helix. And as I said, there's about 1.5 turns per loop in the helix that are electrically isolated from one another. And those are the 3 blocks. Okay, the train is approaching the first gap and entering the second block. So you can see that the second LED has come on, and the other one the first one just went off. Okay, the first one came on when the locomotive entered the block. The light stayed on because that caboose was still within the other block. So we can see as the train progresses through the block, first one light will come on, and then the second one will stay on, and then it will go off when the trailing car clears that block gap. So you can see we're just inside of the second loop. Now we've just crossed another gap, and that third light came on. And when that caboose went across it, then that light went out. So you're able to see the progress of your train, and you're also able to tell whether it's going up or down based on the lights as they come on and off. Okay, we've gotten up here to the top. I'm going to stop because there's no place for it to go up at the end there. So let me go ahead, we'll back on down, and you'll be able to see the LEDs reverse position. So the first one's still on, and it's actually about 1 3/4 turns in this upper section here. Okay, the caboose just entered that middle block, and the locomotive cleared the upper block, so the light went out. We'll continue on down. Okay, the caboose is about to enter the lower block, light came on, and now the locomotive has cleared the middle block. Okay, we're about to come out of the helix. Caboose has just exited. And now we can see the locomotive has exited and the lights have gone out completely in the helix. You could use this type of system in a helix. You could use it on other hidden areas of track under your layout to show the presence of trains, or the presence of cars without having to go with a full-blown signaling system and a computerized system. In a future video, I will show you how I am implementing a full-blown signaling system using the BD20 detectors all over the Piedmont Southern layout. Okay, what I want to do now though is move in closer and show you the inside of the Helix so you can see how I wired it up. Okay, the first thing I want to be able to show you is the wiring here for each level. The Helix itself is divided into 3 individual blocks, 1.5 turns around each. And if you remember from the design discussions, this each Helix loop has a circumference of about 15.7 feet. And one of the recommendations that I make is that with Code 83 track, that you have a set of feeders for these rails every 6 to 8 feet. So that means I needed 2 sets of feeders for each loop of the Helix. So as you can see here, I've got one up here, I have another set down in here, I have another set right here, another set here, and another set down here. And I have the same thing on both sides. It's identical, just mirror images of one another. So the red rail or the red wire goes to the outside rail, the green goes to the inside rail. And that's the detection rail that I'm using. So the 2 cuts that I made in the track are on that inside rail. And that is what isolates these into 3 separate electrically isolated blocks. Okay, so what I've done then is brought the 2 wires down, the red and the green, and I've connected all the red wires together because that's one continuous rail. We can have the wires all joined together and going into one place. So all of these red wires are connected through. I've used 20 gauge wire for my feeders, and that's a 14 gauge wire, that heavier red one in the middle there. So I've just daisy chained these on down, and I've run a single red 14 gauge wire from each side of the layout around to one central point, and I'll show you that in a minute, where I connect it to the DCC power bus. Now with the green wires, I had to do something different because they have to remain electrically isolated until they get through the detector. So as you can see, I've got the green wire here feeding into this connector and this green wire feeding in, connecting to the heavier 14 gauge wire, which comes around to a central location. And then the next block, block 2, same thing. All the green wires, the 2 green feeders, go into this connector and are connected to this heavier green wire. And that goes around to its own central point and connects to a BD20. Same thing down here. I only have one wire, one set of feeders coming in to this one because it's at the bottom. Okay, but again, it's connected to one 14 gauge wire and comes on around. So having these individual green wires allows me to run these through the BD20 detector and therefore give me independent detection of trains within each block. And so what I want to do now is I'll bring you around and show you that central connection point where everything is connected to power and also where the detectors are located. Okay, so here is the central point where everything connects in to power and also where the detectors are located. So you can see down here where the 2 wires, one from each side, the red wires, come together and are connected here in this connector, and they are connected to the DCC power bus that comes in from below here. So that powers the outside rail independently, and it's continuous. Now if we look here, you can see the 2 green wires coming in on the first level, the 2 green wires coming in on the second level, and then up here the 2 green wires coming in on the third level. And then these feed through the BD20 detectors. So there's a BD20 here, a BD20 here, and another one down here. And these are what are connected to the LEDs on that display using the method that I showed you at the beginning of this video. Now this may look like a real wiring headache, mainly because of all these wires over here. These red and the black wires are what connect the LEDs on the display panel to the outlets on the individual BD20 detectors. So these wires have to be very long in order to reach when I eventually place that display on the fascia, because it's going to be about 2 feet out from where you saw it. Hopefully you'll be able to see that. I'll zoom in just a little bit better now. So you can see here on the far right, this is the power wires. So those are coming up from the DCC power bus. And then this wire here goes up through the coil and is connected to our track feeders. So we're actually running the power through the BD20 and then out to the tracks. And that's the way you have to set this up. Well, that's a wrap for today's video. I hope I gave you some ideas on how you might be able to use these BD20 block occupancy detectors from NCE. You could also use the LMID detectors, which are almost identical to these. They look the same. They are made by DCC Concepts in the UK. Here in the US, you can get them at Iron Planet Hobbies. So take a look at those. These are very easy to set up. All you have to do is follow the instructions either at the beginning of this video, or it's all there in the instruction sheet that comes with the BD20. So give these a look and think about how you can use these on your model railroad to show the presence of trains in staging yards, hidden areas of trackage, in a helix, anything like that where you can't see them. You can set up a display like I did to keep track of where they are at any given time. So have a great weekend, have a great week, and we'll see you here next week with another video from the DCC Guy. Bye now.